Next, we try to observe the rusting process. However, this is not easy because rusting is a very slow process. We need to wait, for example, a few days or even weeks to find out the rust appear on the iron object. So what can we do? Here we introduce a chemical called rust indicator. Well, this is a mixture of chemical, and this can help us to show how the chemical reaction undergoes. The chemical name for rust indicator is called potassium hexacyanoferrite. Alright, let's forget the name. It's not important. And also it contains an indicator called phenolphthalein. Now this is important because you will use a lot in the DSE chemistry. Similar to what you have learned in lower grade, for example, litmus indicator, it shows different color in acidic or alkaline condition. For phenolphthalein, it shows pink in the presence of hydroxide ion, that is the alkaline condition. As we mentioned before, when an iron object starts rusting, first it will show hydroxide ion and also along with the iron 2 ion. So first, what is the function for the long name potassium hexacyanoferrite? Well, its function is shows the blue color in the corroded area. And this is because the hexacyanoferrite will react with iron 2 to give a blue complex. So in case you see the blue spots, very good. That means iron 2 exists there. But on the other way, how can we know that hydroxide exists? Now, this is phenolphthalein's turn. Phenolphthalein shows pink color around the whole nail. Now, I rephrase again, this is around the whole nail. Because the iron nail is a conductor, that means the whole nail will lose electron at the same time. And as we mentioned before, because the hydroxide ion is produced, so the phenolphthalein will give pink color to it. And the result will be something like this. So you can see blue color appear at the tip and the end of the iron nail first. The reason behind is because during the production of an iron nail, the head and the tail will experience a heavy treatment or force to make it deform. And as we mentioned before, the scratched or bended surface will speed up rusting. So the iron 2 ion will form there first. And that means these two areas will form blue spot first. Well, finally, some of you may wonder what is the function of the gel. Well, the gel is used for prevent or slow down the diffusion. As we mentioned before, rusting is a slow process in a few days or even weeks. So if diffusion undergoes, then every color will mix together and make us difficult to observe. So the gel is used to slow down the diffusion. And with the rust indicator, this time we try to study the effect of different metal on the iron object. We have two choices. The first one is with magnesium in contact, and the second one is contact with copper, which is a less reactive metal. The result is clear. For the case the iron nail is contact with the magnesium, which is a more reactive metal, the whole nail appear pink. This is because even though magnesium is a reactive metal, but magnesium will lose electron on its own to form hydroxide ion. Yes, iron object will be protected, but magnesium will lose electron and the electron will react with oxygen and water to form hydroxide ion. So the hydroxide ion still exists. Let me highlight it. Magnesium is reactive metal and it will lose electron to prevent iron from rusting. What about copper? Again, the whole area will show pink, but this time something is more. Is the tip and the head of the nail appear blue, while the blue spot is not shown in nail A. It is because iron is contact with a less reactive metal, and this time iron will try to lose electron more readily. instead of copper lost electron. So you can expect the more reactive metal will lose electron first. It sounds reasonable, right? So what about if a bended iron nail is used in experiment compared with a normal nail? Well, I use the word normal. So the result will be both nails shows pink color, but this time the blue color not only exists in the top of the tube, but also in the bended area. Because the bended area, the metallic structure will be weakened. Now we understand how rusting starts, and we should learn how to prevent rusting, right? A simple method is because rusting must form in the presence of oxygen and water. So prevent rusting, easy. Just take away one or both of them. The simplest method is something we call protective layer or protective coating. We have different protective coating, depends on the object you're going to use. But the basic concept is we try to use something to block the metal from contact with oxygen and water. Now, the first part is in case the iron object you're going to protect is a moving object. For example, the gears in a machine. We apply a layer of oil or grease. Because oil and water cannot mix together well, right? So a layer of oil or grease can prevent oxygen or water from contact with the iron. And there is a bonus because the oil can serve as a lubricant. One of the daily example is bicycle chain. But what about those non-moving parts? Oil or greasing is good, but it doesn't look nice. For example, the door handle, you don't want to touch it when it is full of oil or grease, right? So how can we protect these non-moving parts? We got a coating with paint. Again, it prevents the iron from contact with oxygen and water. And we have many cases. For example, beach, ship, or car body. All of them are covered by a layer of paint. So you can see the layer of paint can keep the object safe unless the layer is broken. The third choice is cover with plastic. For example, paper clip or clothes hanger. The principle is the same, so I won't repeat again. Finally, is coated with a layer of another metal. It depends on the object you're going to use. For example, if you want to protect a trophy, so silver or gold plating is wonderful. But if you want to protect a bucket, then zinc plating is a good choice because zinc is more reactive than metal. So zinc plating get a bonus function is even the layer is broken, but the iron object still under protection. In the industrial world, zinc plating is called galvanizing, which is used for those heavy-duty iron objects. But there is a disadvantage for zinc plating. Zinc iron formed is toxic to human. So in case the object is used in food container, we cannot use zinc plating. Instead, we use tin plating for food can because tin is relatively safe. However, the disadvantage of tin plating is tin is actually a less reactive metal than iron. So if the tin layer is broken, then the iron food can will rust faster than usual.